All right, as we have people filing in, I'll do a little bit of quick intros from my side, and then I'll pass it over to you as well, Tuana, just as people are joining into the session here. So from my side, I think anyone who's joined these sessions has probably seen me already. I'm a dev advocate here on the Arise side, so help out with a lot of our events, general kind of go-to-market for the developer side of things, focusing a lot on our Phoenix product, our open source product, but also our enterprise Arise product as well. So you guys probably seen me on some tutorials and events and all that kind of thing. And I'll continue to do all those. And one of the fun things I get to do in my role here is have awesome guests join for some of our sessions. But I'm really excited to introduce everybody to Tuana here, who's joining us from Haystack, DeepSet. I don't ever know which to say between the two of them, but Haystack from DeepSet. And Tuana leads up the developer relations team and that side of the business from the Haystack side. So Tuana, I'll let you give a quick intro on your side as well. Anything else you want to add?
Yeah, well, yes, my name is Twana. I'm based in Amsterdam, so it's probably quite later in the day to most people joining here today. And yes, I'm in the developer relations team. We're a small team and we focus on our open source AI framework, Haystack. So everything I'm going to be talking about today will be using Haystack. And I'll also be doing some live coding, so wish me luck. Well, live demoing, let's say the code is ready. Yeah, thanks for having me.
Awesome. Cool. Yeah, always fun to do the live coding, and I think we've had a few of those on this series already, so you'll be in good company there as well. Cool. So I'll give a little bit of our kind of preamble on these, and then I'll actually pass it over to Tuana and a few slides here to dive into the main topic for today. Um, but just to kind of level set where we are with our agent series that we've been doing, this is our fourth of six sessions that we're doing. So we've had some awesome sessions so far. We started off by going through kind of the intro to agents, talking about different pieces that make up an agent, some common architectures there. We talked about different frameworks you can build agents in. We talked about some ways of evaluating agents in our last session with Vibhu Sapra, who joined us for that, which was a great session. He had some very fun hot takes. So if anyone's curious about his opinions on like VC funding and things like that, we got a little bit sidetracked there into there. So he's got some fun takes from that last session. Today, we're going to end up talking about kind of loops and agents and agent looping and a few other things there. I'll give a quick plug for our future sessions that we're going to have as well too, which is next week we're going to have Jerry Liu from Llama Index, and then we'll have Chi Wang the following week from AutoGen to talk through their own perspectives. Those will be, instead of me, we're going to have, I believe we're going to have our CEO Jason joining those. So we'll have it as like a fireside chat between the two of them. And the other thing I'll throw in here too is that we have kind of added a certification that we're doing along with these sessions. So there's a link there that you guys can follow to go get like kind of certified in agents as we do the sessions. That basically encompasses the sessions that we've been doing here, this sort of six-part series, plus a couple extra things that we've thrown in as well too. So there's some kind of like quizzes to make sure the material's sinking in, some other kind of articles and things like that that are part of that. So that's sort of the series plus, and it's a nice kind of way to wrap up the agent deep dive that our regular folks have been doing over the past few weeks. And yeah, and I mentioned last time we talked a little bit about agent evaluation. So if anyone missed it, we talked through kind of how we could do some of the specific concerns that come up when it comes to evaluating agents in particular. So how do you evaluate routers? How do you think about kind of convergence of agents? Are they making their way to something and kind of making progress in something, or are they following the correct path through whatever kind of architecture that they have? We talked a little bit about some common evaluations that are applied to skills and things like that. So how can you just evaluate a skill within an agent? The spoiler there is that it's very similar to evaluating that same kind of skill outside of an agent. So really the router and the convergence pieces were the stuff we spent a lot of time on. And both of those are actually great segues into what we're going to talk about today, which is all around looping in agents, how to kind of set up the correct path through agents, and how to sort of simultaneously encourage looping, but also avoid infinite loops and some other kind of concerns that come up with that. And so, yeah, with that, I think, Tuana, I'll pass it over to you, and I'll pass it over to you from the Haystack side here. So I'll let you go ahead and share your screen to jump into things there.
All right. Hopefully you're now seeing a canvas screen
Yep,
and hopefully now you're seeing that full screen.
yep, that's what we see.
All right. Well, let's talk about agents in a loop. So I'm going to well, let's go. I've already introduced myself, so we can skip to the agenda. But what I'm going to do is, since I'm going to be using Haystack to show examples of agentic pipelines that loop, I'm going to give a quick intro into Haystack in general so that you have some of the groundwork. And then we're going to be talking about what we call agentic AI. Graphs is a word I add because you'll see why in a bit, with branching and looping. And then we're going to talk about examples of various looping pipelines, and we're going to see how we can trace these types of pipelines as well, because it's going to turn out that it's pretty important that we are able to observe what's actually happening within our looping pipelines. So just for anyone who is not aware, Haystack is a fully open source framework. It's all in Python, and it's for you to build custom AI applications. And the whole architecture is built on two main concepts. Pipelines, which is, you can imagine pipelines as an agent. You can build an agent with a pipeline, or you can think of them as your end application. And a pipeline is effectively made up of components, so intermediate steps that are doing something. And this is a bit of history, but what we now call Haystack 1.x was our first release of Haystack. And effectively, what this was a directed acyclic graph being the important part here. So you had various components, maybe decision nodes, and at the end you had a response. But then a few months ago, quite a few months ago now, actually time flies, we released Haystack 2.0. And the reason we released Haystack 2.0 was actually looping itself, because we discovered that with the new rise of LLMs that are able to reason and iterate over answer, it was very important for us to provide looping as a fundamental thing that our pipeline is capable of. So we effectively got rid of that A in the middle there. So Haystack 2.0 is a directed graph. And these types of pipelines are quite important because it allows us to have pipelines that can invoke the right tool within a loop. It can also self-reflect and correct and iterate through various tasks. So I'm going to talk about looping in two ways. It can be a disadvantage in a lot of cases where we want to self-reflect and iterate over an answer. And I'm going to show you an example of that in code in a bit. We're actually going to build a pipeline that reflects on whether it's extracted the right types of entities from an unstructured piece of text, and it's going to iterate over the answer until it's decided that it's got all of the correct entities out of our unstructured data. And again, it's also very important and quite a big advantage that we can loop, so that we can loop through multiple tools. So maybe a query can be resolved not with just calling one tool, but you need to invoke multiple tools. And we're able to loop through them until our agent decides that, okay, I've got the final answer. I can reason based off of the results of these various tools. Great. But it can be a disadvantage in a plethora of cases, and we're going to only talk about a few. But I've given some examples here. So it can be anything from a hallucinated tool. So we're trying to run something that doesn't exist. The tool call results in an issue. The same tool is being invoked, and we're not able to infer that the answer is there. So there are two things we can do. We can pinpoint and solve the issue. This turns out to be quite complicated if you don't have the right tooling. So this is where we're going to use Arise Phoenix. Wish me luck. I hope we can use Arise Phoenix. It worked this morning, so it should work now as well. And we also need to provide, hopefully, some guardrails. Looping, you can imagine maybe it's not an issue. We just have a while loop, and we have to crash it at some point. But in the real world, we're also making API calls to God knows how many things. You have your model provider, maybe you have a paid API as a tool, etc. And you want to be able to provide a way to make sure that we're not going over a certain number of API calls and racking up a bill. So I'm also going to be talking about how you can provide simple guardrails to avoid this sort of situation. So let's talk about some examples that we can build with Haystack. And the first and simple example that we're going to see live in a bit is self-reflection. And I see a situation where things might go wrong. For example, in Haystack, we have a tool called the prompt builder. This is where we create a prompt that we can then augment with some information. And let's say this prompt builder is being provided with some text, and we want to generate something based off of that text. We have a step that I'm just going to call reflect here. We'll see how that works in a bit. And this reflection step can result in, okay, great, you have the right answer. I infer that you have the right answer. Or it can say, no, we don't have the right answer. Let's go back and let's try again. What happens if the generator step results in A? So we've got A, we're reflecting on A, and we're saying, nope, A, go back. This is wrong, try again. We go and we have B, and then we infer that this is also wrong. And then we try A again. And this actually surprisingly happens quite a lot. My colleague pointed out a great quote that we think, apparently it's from Albert Einstein, insanity is doing the same thing over and over again and expecting different results. And this is something that happens with self-reflection, that we end up with the same result over and over again, but we aren't able to improve on that result to actually get out of the loop. And here there are a few things we can do. Number one, maybe the problem is that we haven't provided memory in the right way for this type of self-reflecting pipeline. Maybe the pipeline is not aware that A was generated in a previous step. Or we don't have the right exit route. Maybe we don't have the right kind of thing to say, okay, after a certain number of tries, you have to ditch this scenario. Another very important reason we use looping, and this is, I would say, now the most common reason, is we may have an agentic pipeline, and ultimately a generator in this case, or let's say an agent, has access to a number of tools. So we already provide it with a number of tools. So let's say tool 1, tool 2, tool 3, and these are things that are available to our agent right now. But things don't always work the way we want it to work. And let's say our generator picks a random tool that does not exist, a hallucinated tool. And the result here is something that's just wrong. We have an error. And we try again, and we hallucinate a tool again, and we try again, and so on. Or even, I would say, in some cases, probably a bit easier to handle. But let's say our tool 3 is making an API call to something totally different. Let's say we're trying to figure out what the weather is in a certain location. And this is actually a tool we're going to use in a bit. And let's say that results in an error 404. If our system isn't able to deal with that kind of error, we're going to continuously pick that tool because for some reason we need to find out what the weather is in a certain location. And we're going to be stuck in a loop again. And then the final one, and I think this is probably the one that is the most infuriating because it can take quite a few tries to get it right, is our main agent prompt not being structured correctly. So we're not actually providing any instruction for this type of agent to decide that it should exit. For example, always continue by selecting the next tool. And that means that our application is just going to continuously select the next tool, even though the tool has resulted in an answer and we're supposed to exit. So these are just some examples of how things may go wrong and how we can start looking for where the problem is.
Hey, Tuana, sorry to jump in. Just a quick question that came up that might be good to tackle there, if that's all right.
Yeah.
Sorry to interrupt. There's a question around how you know the correct answer during that reflect step. And so I'm curious, is that something that's, the correct answer, or is it just that you're checking for failure states? I guess or maybe you're going to tackle this later as well too.
We're going to see that in code. So yes, it's how do we know what the correct answer is? This totally depends on what your application is. So I'm going to show a very, very simple case. I'm going to have a system where if the large language model has generated all of the entities, then it's also going to have the word done in the result. And that's basically my very simple way of showing you how you might decide whether something is correct or not. But this completely depends on your specific application. And here, actually, this section might make sense for this reason, because most of the time what we see is people build their own custom components, which is the reflection step that has their own conditions to decide whether a generated reply is correct or not, or is the right thing or not. Hope that makes sense, but I'll show you an example in a bit. All right, do we have more questions?
Looks like there's a few others that have come up as well if you want to tackle them now, or you could kind of wait until later on, up to you. Some of it's around, it's kind of more thematic around the sense of, I think going back to what you're talking about, the directed graph approach,
Yeah,
and that sort of architecture.
yeah.
So there's a question around whether you see kind of like with those pipelines, you see things moving almost closer towards data engineering versus like a kind of broadcast event receiver sort of model there. So I'm curious if that's something that's ever come up on the direct graph side of things.
Um, yes, I see. Yeah, I would say so. Again, it depends on exactly what an individual component is doing. In a lot of cases, a component may simply even be a very simple if-else statement that in a lot of cases is super useful, in which case there's nothing fancy going on there with a large language model generating an undeterministic response or not, but you're just using it as a switch to say, okay, now I do this. If not, I do something else. Um, and yeah, in that case, I think it does sort of start getting closer to more simple data science steps in your whole AI agentic application. But at the end of the day, you're still relying on a previous step that's generating a response, and you have no idea what that response is going to be by nature of a large language model, if that makes sense. But yeah, I'll continue with the building blocks, and maybe once we switch to the code, it starts to make a bit more sense. So I talked about all of these types of pipelines where we are able to loop and decide whether we have to continue or not. But what I didn't talk about is how these things are even combined and what they consist of. So the main building blocks I mentioned with Haystack are components, and we're actually going to build our own components in a bit. And actually, I'm going to build a component that is the decision or reflect node, if that decides whether the correct entities have been extracted or not. So there's only a few things you really need for something to be a component for Haystack. And you need a class that is decorated with as a component. You need a run method. And when you have this run method, these inputs here become inputs to the component. And you also provide output types. This is, if you remember that graph structure I showed you, as you can imagine, like a component is outputting various things of various types. And this component output types decorator is able to then validate that our graph, it actually makes sense. Like our graph is indeed valid. If something is expecting messages, but it's receiving integers, then there's a malformed connection there. And then it returns something. In this case, it's returning an output that's empty. And in the haystack world, this is actually a totally valid component, even though I'm not returning anything. This is also a totally valid component. So this is an example I like to show. I've created here my own translator component. It's a custom component that takes three things in: from lang, to lang, and documents. And then it returns documents. And the documents it's returning is all of the translated documents. Obviously, here I'm returning an empty list of translated documents, but yeah, this is where we start to build out our own components. So I'm going to build a component that I've called very creatively entities validator, but the whole point here is extrapolate that to things that you might need to validate, something that you know exactly whether it's true or false, etc. We're going to be building a very, very simple use case. But the whole point is how you might implement this type of looping. The other thing I need to point out, because it turns out we use this a lot, especially for self-reflecting pipelines, is that the prompting with Haystack happens with Ginger templating. So here you have a bunch of, again, totally valid prompts. For example, for question answering, you have the instruction given the documents answer the question, and you have documents in question. Everything you see in curly brackets immediately becomes inputs. We're expecting documents and question as inputs to our pipeline. So now let's switch over to Colab. And this is where you wish me luck. So I've already set up everything, and I think I sent over the Colab. So if you like, we can already send that in chat, and you can already start running this if you like. And we already have this Phoenix tracing set up, and there's nothing in there. And we're going to start seeing how we can start tracing looping pipelines. So hopefully all of that should work. Okay, so this is where I think the question, how do you know if something is correct or not, can be answered. Now, in this case, in my scenario, I'm doing something very, very naive. I have a component called the entities validator, and it's supposed to be receiving something called replies. And if the replies has the word done in it, we're just going to say, okay, the large language model has inferred that it is done extracting all entities. Obviously, this is a very naive situation, but your entities validator or your, let's say, checker component may do something totally different. And in this case, we're going to be outputting entities. But what we're doing here is kind of special. We have an if-else block, and we're telling the graph that this component may output one of two things. And in the case that we don't have done in replies, we're going to actually be outputting something called entities to validate. I'm just going to make sure that that's okay. So as an example, here I have replies that contain name Twana. So I've extracted the entity name Twana, but it doesn't have the word done in it at all. So it's actually outputting entities to validate. And in another scenario, we may have this and we are outputting entities. So we're done with extracting entities. And what we're going to do here is we're going to create a prompt template that looks kind of complex, but it's actually only using a segment of the prompt at any given time. So if a generator or entities to validate returns to our prompt saying there are entities to validate, we have a completely different thing that is meant to be there as an instruction to reflect on the generated responses. So here we're going to be saying your task is to extract entities from a text. You've had a previous attempt. I already see that there's a typo there. And here was the text you were provided. And we're going to be asking for something called text. And here are the entities you previously extracted. Now I've already embedded an error into this. So we're going to be able to see what's going wrong with Phoenix. But if there are no entities to validate, so this is basically our original instruction, we're informing this whole system to extract entities from a given text, and that the entities should be person, location, date. In an ideal world, we could also even make entities an input to our prompt. And then we create our graph, let's say. I'm not even going to run this. Maybe I should run it just to make sure the pipeline is created because it's been a few hours. And we can also have a look and show what this pipeline is doing. And you can see that there's a loop here. So we have our prompt builder, which is our prompt. Our prompt is being provided to a large language model. In this case, I'm using the OpenAI generator. And I think the default model now is GPT-4o mini for anyone interested. And then we provide the generated response to our validator. So this is, imagine it as these two being our reflection step. Our entities validator is then, if there are entities to validate, is going back and we're trying over and over again. So let's give that a go and hopefully we do get sometimes GPT-4 mini or GPT-4. Well, most of the latest ones are too good and we just result in the right response immediately. But as you can see, here's a previous run I did. And the first thing that you see in red is when it's decided that it is not the right answer yet. And then the green is the right answer. So you can see last time it extracted the location, but it did not have the other entities in there. So hopefully we do this. Okay, so the first time round, you see that it's extracted quantity, which is not anything we asked for. Then it also extracted miscellaneous, again, not something we asked for. And then last iteration, we got date and person, which is actually good because we did ask for the entities to be extracted with an empty list, even if there are no entities that belong to that category. And then here's another one I tried today. And let's see what happens here. And voila. So these are meant to be sort of meeting notes. We've got person, location, and date. Now, I thought everything was going well here until I had a look at what was happening in Phoenix, because there's actually an error in what I've built. And this is working in some cases by chance even, in largely because the model I'm using is a pretty good model. And all I have to do is, you can see I've run the pipeline twice. I go in and see what's going on here. So the first thing I have here is I'm seeing that my prompt builder is being given the text I provided. So here are the sort of meeting notes I provided. And then I'm looking at what it's outputting. Oh no, I think I've fixed it. Sorry, guys. Previously, I wasn't getting the text in there at all. Oh no, wait, hold on. This is not where it is. Let's go to prompt builder. Yeah, okay. So the prompt is being augmented with the text, and we say, here are the entities you previously extracted. But as you can see, that is completely empty. So at each iteration, it turns out I'm not actually providing what the model had generated in the previous step. So we can then go ahead and fix that. And the reason for that is that we only looked for the first character in our extracted entities. All right, so now I'm going to go on to a slightly more complex example. So this is the example, John, that you had also used in our previous live stream last week. And what we're going to be doing in this scenario is, this is not a self-reflecting agent. We're going to be creating a chat agent that has access to various tools. But in some cases, the query can be resolved with one tool, and we can exit the loop and provide an answer to the user. In other cases, the question requires us using more than one tool. So we need to first run one tool, then we need to provide that answer, loop back, use another tool, and go on until we've resolved the slightly more complex question. I've already done this, so I don't think I have to run it again. But what's happening here, just in case anyone is wondering, is we're populating a document store. So we're storing a bunch of dummy data. So we have various names and where they live. And we're creating embeddings for them, although it's probably very unnecessary for these types of sentences. And we're just adding them into an in-memory document store. I don't think I have to rerun this. If we do need to, I'll come back to it. And here's where things get interesting, because one thing I'm going to do is I'm going to create a classic RAG pipeline. I just have an instruction to answer questions based off of some content. But I then want to provide this whole RAG pipeline as a tool in itself. So here things start to get exponentially more complicated, because anything can go wrong, from it being within this RAG pipeline to another tool being run in a wrong way or anything like that. So the way I do that is I just wrap that RAG pipeline in a function, and then I define it as a tool, and we give it a description. So get information about where people live. That's basically it. And then another thing I'm doing is I'm simulating a weather app. So I think it would be way cooler if anyone builds this with an actual API call to a weather app or something like that. but we've simulated this. So we have weather information on Berlin, Paris, Rome, Madrid, London. So the idea is that this tool should be run if I'm looking for the weather in a certain location. So we get the current weather for a location. We also have a fallback. Obviously, these aren't all of the cities that the planet has. So if there are no cities, if the city that you're asking for isn't provided, we're returning a default 21.8 Fahrenheit, which I found out is apparently really cold, but everything else is in Celsius and I don't speak Fahrenheit. So yeah, so this is a tool to get the current weather for a location. I created for my own use case, a message memory component. That's fine. And then we're creating a chat agent. I'm not going to go through all of the details in this code snippet because I think we can look at it. So our pipeline always has access to memory, and our generator has access to various tools. So if the generator says, I need to call a tool, we call the tool. And if it decides it has to call a tool again, we call a tool again until our generator says, okay, the reason I'm exiting this loop is because I actually have the final answer. So I exit the loop with final replies. And this is where you can then run this pipeline and hopefully it works and you have a chat app that, for example, let's say, where does Mark live? So that's one pipeline call. What is the weather like there? So hopefully it answers about the weather in Berlin. Great. So in this case, because we have access to memory, first we're running the RAG pipeline to find out where Mark lives. And then we're running the weather tool to find out what the weather is like where Mark lives, which is Berlin. We already know that it's Berlin. The next thing we could try is try a slightly more complex question that will require the pipeline to have to use both tools one after the other. So we can ask, what's the weather like where Harry lives? Harry loves. All right. Harry lives in London and the weather there is cloudy with a temperature of 9 degrees Celsius. Now, I want to scroll up to see how you can make sure exactly the order in which various tools are called and whether they are responding with the correct results or not. So this is where, again, this morning it worked. So let's hope it works again. So let's have a look at the final one we called. Oops, this is not the right one. I need to scroll up. Nope. Why is it not showing the tool invoker? So we're
Live
getting all,
demoing,
yeah. It did
always
show the
something.
tool invoker this morning, so and we do have the
Yeah.
tool invoker in the pipeline, so surely it should. Should we try another one?
Yeah, we can try one more. I wonder if it's I know that we've connected to pipelines specifically, so I wonder
No,
if
no,
there's
it
some.
did show the tool invoker this morning,
It
so it
did. Okay.
definitely should. Yeah, yeah, yeah. We can try
All right.
rerunning the pipeline. Is someone having trouble getting access to the
I think
Colab,
we
by the way?
Sahar, I think it was Sahar, and I think we're okay now based on the messages in the chat.
Oh,
So yeah,
so interesting. Okay,
if anyone's
I'll
having trouble
exit this.
accessing the notebook, let us know and we can make sure.
All right, let's rerun the pipeline and see if our tool invoker is going to be showing. Because normally you have to be able to see the internal pipeline of the RAG tool that we used, which is what I wanted to show. Let's see, what is the weather like where Harry lives? Where does Harry live? Oh, you know what? I think it might. Okay. Okay, it decided to not pick the first tool, but then it figured out it had to pick the tool and then the weather tool. Okay. Now let's exit that and see what's happening here. And if not, we may have a bug to fix, John. Oh no, I think you can see tool invoker is now available. Okay, so now we can see exactly what's happening in each step of our pipeline. So the first one decided that the answer was there. And then we have the tool invoker, and you can see each step of what's happening in that tool invoker. First, we're using the sentence transformers text embedder to create an embedding for our query. Then we're retrieving documents. Then we're generating a response saying that Harry lives in London. And then hopefully we are able to see the second tool invoker. And this is where we can hopefully see that it's deciding to use the, where do we see it? Yeah, the weather tool with location London, and it's resulting in the weather information we have in London. One last thing I want to show is breaking this. So I tried quite a few times to get, so OpenAI models are actually quite good at this kind of thing, I would say. But I tried quite a few times to get a pipeline to continuously try call the same tool over and over again. So I broke the weather tool and I tried to use GPT 3.5 Turbo to see if we could break it. We can try that as well. And then there's one final thing I want to show everyone that you can use to make sure that you have guardrails in place. So instead of returning the weather information, let's just say try again at each step. So whatever we ask, our fake weather API is going to be returning try again, which could actually happen in the real world as well. We may have a situation where an API is returning with a 404 or try again or something. So let's do that. And then let's also switch over to GPT 3.5 Turbo. And let's create that pipeline. And I want to try and get it to at least try a few times calling the weather API. Usually OpenAI is actually quite great at this and decides if it's been told to try again, that the user should be told to try again is something that I've noticed. But let's give it a go. What is the weather like in Berlin? So it's definitely trying a few times because this is running. That's nice to see. Okay, actually, I'm going to stop it now because I don't think my company would be happy with racking up an open API. Let's see what's going on. Okay, yeah, as you can see here, we have tool invoker, tool invoker, tool invoker, and so on. So what can we do to avoid this kind of situation? Number one, we could have a better prompt that is able to instruct the large language model to say, if you've been told to try again, please exit, or anything that may be relevant to your scenario. But the other thing that I kind of skipped showing you was this max loops allowed. So this is what we had in our self-reflection pipeline. And this is a guardrail we have in Haystack, which is setting the maximum bound at which the same component can be run over and over again within a pipeline, ultimately resulting in a loop. So in our self-reflection pipelines, we are making sure that if we are hitting 10 loops, we're just exiting. And this is just a last case resort, a scenario that hopefully you don't have to hit, but it's just there to make sure that you're not going over a certain number of loops in your pipeline. We never got there with the self-reflection because the entities example is pretty simple in my opinion. But if we had, and in some cases with various model providers, you do, it's nice to have utility to make sure that you're not going over a certain limit. And yeah, max loops is yeah, pretty brutal. And yeah, that's it. Are there any questions? Let me see.
We've got
Uh,
one question in the Q&A as well too that we could tackle.
yeah, I'm trying to read through it, although my eyesight is not great here, apparently.
I'll read it out as well, so it goes on the recording too, because that's always good to have that there. So there's a question in the Q&A around. Um, I've seen that if I do not mention in my prompt that it must consult with or something along those lines, it goes on its way and hallucinates for not having consulted with the right resources. So I guess there's a question here generally that I would maybe pose around like things that you've had to include in prompts to get them to work correctly. I think you've mentioned a few of them, but I guess how do you think about structuring like a almost like a system prompt for your agent? What are some of the things that you typically need to include in there?
One thing I always say is actually, I don't really agree with having just a general answer for prompts overall, because in my experience that this really highly depends on the model provider you're using in combination with the prompt. So there are so many scenarios where a certain type of formulation or a certain style of prompting works with an OpenAI model, but not necessarily Gemini, for example. You also have a lot of model-specific tags that might work well with some models versus others. So in this case, it boils down to researching what that model expects as an instruction, making sure that your model is, yeah, it's an art, not science. Is actually, I love that terminology there. And it can result in a lot of trial and error. Um, we've seen situations where uh, over explaining something, especially with an OpenAI model, actually results in less good results than being to the point and giving bullet points as to this is what we need, this is what we do not want, etc. As you can imagine, coming up with this prompt here took me quite a few trial and errors, to be honest with you, because I wanted something very specific. I wanted it not to just be these entities, but to make sure those entities were provided every time. So even if there are no dates, I want dates with an empty list. So it was quite a trial and error. So I agree with it's an art, not science.
That makes sense. And I guess just my own curiosity, how do you think about like structured outputs and some of those kinds of updates where you have models that are able to kind of conform to structured outputs? Like I see you're kind of going for something like that here, but like is that something that you see a lot of people using or some people avoiding?
Okay, so that's a very good question because the first looping based example we had in Haystack and it's still on our tutorials was a autocorrection example. And this is, again, I think it goes back to that question that someone had. How do you decide if something is right or wrong? In my case, I built a very naive entities validator that's just looking for done or not. In this case, what we were showing is how you can use Pydantic and for example, here we created a model, cities data, that's a list of city. So we already have the model and we have Pydantic to validate that a structured output is abiding by that model. So we still use this as an example and people still use it and it is a useful step. My personal experience is the structured output, which is albeit still in beta with OpenAI, is already very, very good at this. And I would assume it's doing something similar under the hood because you are providing it with a Pydantic model to be able to generate the structured output from. It was my first time using it a few days ago for the query decomposition example. And it was perfect.
That's great. Yeah. Um, Yeah, it's funny seeing Instructor, a whole package that supported that, and their reaction to OpenAI releasing that feature. It seems like it's something that will be in most models very soon
Yeah.
because it's working. We have another question as well too. So Blake asks around no code or low code kind of visual development frameworks. So you mentioned that what we've seen here is code. Do you see a no code or a low code kind of development framework as something that is going to grow in popularity? Is that something that Haystack thinks about at all, like to kind of add more abstraction to do something along those lines? I guess what are your thoughts on kind of the no code or low code orchestration framework approach?
Let me try login here. I find it very convenient that this question came today because it's still waitlisted, so you can still sign up, but this is actually something that we released recently. So for anyone who doesn't know about the company, so Haystack is one of our products. The name of the company is DeepSet though. And we have a SaaS tool called DeepSet Cloud. And we just released this other one that we're calling DeepSet Studio. And it's actually meant for this purpose, that you can build these types of graphs visually rather than relying on first building with Python and then yeah, visualizing them with Phoenix. This is just for the pipeline building step though. So you could go ahead and build these types of pipelines, looping pipelines here, and then you can export that to Python or YAML, and then run that, and you already have the pipeline ready. So to answer the more overall question, yes, we do see this type of tooling being very useful, especially because of this whole graph component pipeline structure that Haystack has. I find it a lot more intuitive, especially like you saw just now, even with a few components, the tool calling chat pipeline can get quite complex. So I always use the show functionality to make sense of the thing that I built and make sure that the connections I have is what I wanted and the loop I have is the loop I wanted. So this is quite useful.
It's interesting seeing too that you got that abstraction, but at the same time you're exporting to code, so you could always go in and modify the code. So you kind of like
Yeah.
it's a move towards more of abstraction, but it's not full kind of.
Yeah.
It's a good balance, it seems like, between the two.
Yeah. And it doesn't have tracing or anything in there with it right now. So you would export that code, bring it here, and then hopefully, connect it up to something like Phoenix, and then you have all of your traces there.
Yeah. Let's see another question coming through. Um, yeah. Looks like there's another question around other kind of some other frameworks that adopt a similar approach. Um, I think maybe we skip past that one, Blake. Let me know if there's a question in there that you want us to tackle as well, because it seems like you're highlighting a couple other tools like
Oh yeah, okay, I see.
some other approaches and things. So happy to dive into something there, but let us know if there's a question there. Um, I guess one other question I would have is the sort of memory and state element throughout and
Yeah.
the pipeline here is something that we talked about in the series a little bit, but we haven't necessarily covered too much. Would you mind just like sharing a little bit of how you're approaching like the memory and state thing? I think we saw a little bit of it, but I think it'd just be helpful to get a better sense because this is such a tactile example for folks.
You actually saw what me and my colleague Stefano built. So that's not
Mm,
actually any official memory functionality we're providing. It was just a very easy thing to set up. I was just keeping a list of message queues. That was basically it.
yeah.
And I think maybe someone pointed that out to the point, the entities extractor, and I hinted at that in the slide deck as well. That this is very prone to, especially I think if we were to change the model to go result A, B, because it doesn't actually have any, I'm not keeping any queue of the entities that were extracted, all of them. At any given time, that example has access to the one previous generated entities. The way we're approaching it right now, which I'm seeing other frameworks also adopt this alongside other um, sort of technologies as well, is we're in a way extending our document stores. So we're reusing our document stores to be able to have a message memory as well. And in a weird way, even the memory itself can be in itself a sort of RAG pipeline or a filter retriever pipeline. So that's how we're approaching it right now, and it's all in our experimental package. So the experimental package gets installed with Haystack by default, but you do import it from Haystack Experimental. And we're iterating on that idea to see if we can increase the capabilities of the pure document store to act as a message and tool call result memory queue.
Interesting. So you're almost adding like a maybe not RAG, but just another kind of stored tool that you're using to be able to retrieve memory and messages, whatever you've included in there. That's cool. Um,
Yes, and
yeah.
that could potentially mean that you could then decide what the back end of that memory is yourself. So we would then be able to be quite agnostic when it comes to that. And we expect to see some people say, okay, I'm going to use Redis for memory. Oh no, I have, I don't know, Weaviate set up already, and I'm going to create another instances in Weaviate, and that's going to act as my um, agent memory.
That seems like it would set you up for increasing a lot of what can be stored in memory as well, too, which is kind of useful for
Yes,
more complex agents. So that
yes.
that's interesting.
What I'm finding very interesting lately is that, so I'm sure a lot of you have heard about GraphRag, and I think that type of implementation, graph structure for memory could be quite interesting. I have not tried it myself.
Yeah. Yeah, we've definitely had some folks bringing it up. I don't think we've actually covered it too much on this series, but we have a little bit of other stuff we've released around it. It seems like it's really interesting, but you have to kind of build the graph itself in the beginning. Comes like it's almost like a sort of not barrier to entry because a lot of things will do it for you, but there's like that sort of barrier to entry from a compute perspective in a way. So that's interesting that GraphRag has become. I could see it working well for memory and or like a longer standing kind of thing that you're going to use in that approach as well too. Awesome. All right, I'll do a little last call for questions here, and as well. Just want to say a big thank you here too to Tuana for joining us. I am going to go ahead and pull up one more slide here as we say our goodbyes. But thank you everybody for joining us here. If anyone's got any last questions, we'll hang out for a minute or two just to go through those. If you haven't had a chance to check out Haystack, definitely go check it out. This notebook's a really great example. It makes it really easy to build a lot of different pipelines and things like that. And I think I recognize a lot of the names in the chat, but if anyone hasn't checked out Phoenix or Rise as well, go ahead and give Phoenix a try through that notebook or just through our GitHub repo as well too. Thanks for everybody joining in. Thanks for the great questions as well. Always fun to have a live coding session. So I'm glad that all went smoothly. So that was great to see. But yeah, we'll hang out for another minute or two in case anyone has questions. And thank you, everybody.
Had me worried there for a second, but turned out it worked fine, just rerunning it.
Honestly, it's more impressive when there's like some sort of issue and then you're able to resolve the issue live. I feel like that's almost a increasingly cool thing.
I do wonder, oh, you know why it happened? It's because I ran the pipeline before the session.
Mhm.
So it already had the answers in the
Oh,
message queue, so it never had to. So restarting it did actually work.
interesting. Yeah,
Oh, no.
yeah. Being able to examine that memory of the message queue, I think, is something that would be helpful to be able to have it maybe more from our side, from the tracing perspective. It's like, how do
You
you
can.
see?
It's just
Yeah,
quite dense. So you
yeah. It's
can
like
see the
not parsed
message
out.
queue.
Yeah, we might want to add some sort of memory, like pane or something like that. Um, awesome. All right, I think we're probably good on questions, so I'm going to go ahead and end it off here. But again, Tawana, thank you very much for joining us. Really appreciate it, and thank you everybody for listening in. Have a great rest of your day.
Thank you.